There we go.
Oh, perfect.
Yay!
Awesome.
I don't know why there was so much trouble this morning.
Yeah.
Well, when I started the original one, no, it always asks you if you wanna, I think like invite other people, and it says like skip or invite, but I was clicking skip, and then that little box just wouldn't go away.
Oh, yeah, that's usually when I invite everyone. You just type in like the first letter, couple letters of the name of our names,
Uh-huh.
and send the invite, and that's it.
Okay.
Sadie's still not getting it. I think at the top of the Google Hangout on yours, you can actually invite people.
Yeah, I did. I sent one to everyone, but I'll send one to Sadie again. Okay. Let me tell her real quick. Oops. Oh, no, go back, go back, go back.
Oh, Sadie's here.
Oh, is she? Ah, there we go.
Yeah.
Yeah.
Good
Okay.
morning.
Yay. Sorry about all the snafus. All right. Where are we at here? Let me just get my screen set up.
You.
This is. Oh, that's the answer key. Okay. Answer key. Did everyone have a good weekend?
Yes, thanks.
Yeah, it was pretty good.
Nice and fun. Okay. So, part 2. All right, so starting with number 6. So what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? And that, wasn't that on the top part of the...
Yeah, so it's going to be that it's a simple random sample, that it's normally distributed, and that the sigma is known. But sigma is just standard deviation,
Yeah.
right?
Yeah, yeah. Yep. Okay. That was pretty simple. All right, so... The Graduate Management Admission Test is used as an admission criterion in many Masters of Business Administration programs. The BYU Idaho professor would like to estimate the population mean for a simple random sample of 50 people's scores. Yeah. Sample mean for these 50 students is 541. Assuming a population standard deviation of 32, answer the following questions. What is the point estimate for the population mean?
550, 541, right?
Yeah.
Stays the
Yes.
same.
Okay.
My paper.
Which is, let's see the answer key. Yeah, 541. Okay. And then create a 95% confidence interval for the population mean. Show your work below. Well, I'm not going to show our work below, but okay. And I actually didn't already go through and do all of this. Okay, so we're going to use the formula.
Yeah.
It's the little e, right? Is that the one?
It's X bar plus or minus Z score times sigma over the root n.
Okay. Gotcha.
Here's my calculator.
And so we need to compute it for both the plus and the minus.
Okay, and so for 91, what was it, 95%, our z-score is...
1.96.
1.96.
Okay.
In the homework, it asked us to round them up, so I rounded. I used, yeah, something to the hundreds instead of thousands.
So I guess I don't think I have the same formula.
Do you have
What are you using?
bar? It's like I think it's an R X with a bar on top minus Z
Plus or minus Z. Yeah.
times standard deviation over the square root of
N.
Okay,
the sample.
can you say that again? For me.
You want me to screen share?
Yeah.
It's actually the formula that's in number 3 of part 1.
All right, let me see. I have something totally different.
Did you check your answer key?
Yeah, and it's similar. It's not quite where it should be.
Here, let me show you. Let me screen share.
So part.
Individual preparation. Well, let me just click this one. Okay. So here's the answer key, and it is number 3 right here. See that? Let me make it bigger for you. Right there. Can you see it?
No.
This highlighted.
Oh, okay, yeah.
So it's this one that we're using, the plus or minus.
Okay, yeah.
You have to do x bar plus and then x bar minus.
Yeah, I was just using the formula that was in the book, which is very different.
Which one is that? Is that the m equals?
Yeah.
And I think that one is kind of the same, isn't it? Did you already do the math? Or the one to the right, or x plus or minus m, right? Was that the
Well,
formula?
in the book I saw something that said 2 times the standard deviation divided by the square root of the number.
Okay.
So I'll use this one.
Stop screen sharing. Are you guys done? Giselle and Natalie, are you done doing your?
Yeah.
Okay. So
Yeah.
what did you get? What did you get?
Yeah, I got. For the minus, I got 532, 130052, blah blah blah. And for the plus, I got 549.8689, blah blah blah.
Yeah, that's correct. That's what the answer key has. So that should be the correct formula then.
Yes.
All right. Well, I didn't do that. Sorry. Let me go through and just at least write it down real quick. Sorry. Here we go. Sadie, if you use that other formula, do you get the same answer?
It's similar, but a little off. But I guess this makes more sense.
Yeah, in the book I was confused as to why we're using that to. Oh, because in the book the margin of error was 2, I think. So they were.
Oh, okay.
That's fine. Okay.
They might have been using like a different confidence interval.
Oh, my brain just cannot catch up this morning. Sorry.
You're fine.
Yeah.
This homework, like, this time it took me so long, so many times to read the thing to, like, kind of digest it in my brain.
Right. Okay. Do you guys want to move on to 9?
Yeah.
Okay. So say the sample size changes to 100. Now compute. So do the same thing, but just change your sample size. Okay. So it's going to be... Okay. Okay.
Did you bring that for Brendan? Thank you.
Are you on those ones?
What was that?
Can you see me?
Okay. Everyone done?
Yeah.
Yep.
Okay.
Yes.
What'd you guys get?
534 for the minus. Well, 534.728, and for the plus 546.
Uh-oh, she froze. So for the plus, I got 547.272. Is that what you guys got?
That's what I.
Okay.
Yeah.
And where is my answer key? Sorry. And what were we on? 543.73. Yep, if we round up, and 547.27. Yep. Okay. So that's correct.
Okay, we go through 10.
Yeah. Okay.
Okay,
So
because I got disconnected. Sorry.
okay.
So,
How does the
okay, so,
error for 95% confidence interval of the samples is a 50 compared to the margin error for the 95% confidence interval of the sample size of 100.
I would say the margin of error for the 100 is smaller.
Right?
yeah, the margin of error gets smaller
As the sample
when the
size
sample
grows.
size increases.
Yeah, correct. Okay. So 11. Create a 90% confidence interval for the original 50 students. Okay.
So we use a normal probability applet, right?
Yeah. To calculate for 90. Where is my applet?
1.6.
Well, if you go in the readings, it also gives you the most common ones.
Oh,
and
yeah.
it's 1.65.
Is it 1.65?
Because I had
For 90?
no for 90. Well, because if you it's 1.645. But when we answer the questions on the first page, it asks us to round them up. So I don't know if they want us to use the roundup or the.
No, I think they want us to use the whole number, right? 1.645?
Yeah, I would think so.
I agree.
I would think so.
Okay.
Okay, so for the original 50 students, so it was 32 over the square root of 50, right?
Yes. Minus this number, 41 plus this number. Giselle, I think the numbers that we round are the very last bit, the very last numbers, our final answer.
You know what? It doesn't. Yeah, it doesn't really matter. I tried it with both on the first one. The difference is not that big.
Oh, yeah.
Yeah. And if you run the node app, it's 533.5229, and if you don't run the app, it's 533.5555. So.
I 3.5. And then now just click that. Is that what everyone got?
I got, yeah, 533.555557
Yeah.
and 548.4444, 2 point something.
Okay. What do we have here? Yeah, so the key says 533.56 and 548.4. So we're good. Okay, so how does this margin of error for the 95% confidence interval that you computed in part 2 compared to the margin of error for the 90% confidence interval that you computed in part 1? Is that 5? 4? I forget Roman numerals.
I would like it if you didn't take them out.
Okay, so we're on 12, right? So the margin of error decreases along with the level of confidence, yeah.
Yeah, the margin of error gets smaller as the level of confidence grows smaller. Okay. Okay, so everyone understand that?
Yes.
Okay.
Put it in until you get me the back. Can you find it?
13. So the BYU Idaho professor would like to repeat the experiment, but he wants to make sure he has enough students in the sample to make sure the margin of error is 5. How many students will need to be in the sample to ensure that he has this level of accuracy for 95% confidence interval? Okay, so this is a different formula.
This one is N
This is the one
equals Z. Yeah.
Yeah.
It's Z times sigma over M. And all that to the square.
There we go. Yeah. Okay, so we're going to go. Always have to write the formula down.
Yeah, I don't know where the formula is.
It's in the reading under 5. It says sample size calculations.
A sample size formula. Mm-hmm.
Yeah.
I don't see 5.
Just scroll down until you see. Let's see. Okay, so up at the top, click. And when you're in your reading,
Yeah.
Just go down to 5 and click sample size calculations, and it'll take you
Oh, yeah. Okay, I'm there.
there. And their formula is right there. The n equals z to the asterisk or whatever, sigma over m, all squared. You see that? You want me to screen share?
Yeah, I don't see it.
Okay.
I see the formula we've been using.
Let me screen share. It is this one right here.
Oh, okay. There it is.
Okay, cool. Over m, and then all squared. Okay.
Okay. 157.35,1936, which we then round up to 158 because we just have like a
Okay.
small piece of a person, you know.
Oh.
So
Hold on. Let
the
me.
answer would be 158.
Okay. Let me do the. Let Sadie and I do the calculations real quick, and then.
So are we going to use the 8.87 for the margin of error?
He wants 5
Well,
margin of error.
Yeah.
Oh, okay, there it is.
So we're doing for 95%, which is what's the z-score for 95% again? 1.9
1.96.
what?
96.
1.96. Okay. Times what was our? Sorry, ladies.
You're fine. You're fine. Just take your time.
32 and m is 5. Okay. And then we square all that. All right. I did all this stuff. What was it?
Did you say 158?
Yeah,
Yeah.
just round it
Oh,
up.
okay. That's what I got.
32 equals 62.
And we technically get 157, but point something something, but for these ones you always round them up.
Whoa, what the heck? I know what I did. I forgot to put my decimal point.
Oh, I do that too sometimes. Why is that number so big?
Yeah, I'm like, what's going on? Divided by 5, here we go. I'll catch up to you. 12.544 squared is 157.3, which would be 158. Okay. Sorry. All right. Woohoo! All right. Good job, ladies. Are we ready for the group quiz?
Yes.
I don't know. Are we ever really ready for the
I
group?
know, right?
You don't feel ready? Is there something that we can help you with?
No, I just never feel ready for the group quiz.
I am the same way. So,
Are you ready to
need
start?
open it.
Yeah.
Give me a second. Okay, yes.
All right.
Just loading. There we go.
Is... Yeah, we want to put an E in. 90% confident in all.
Okay.
So the normal probability output.
Okay. Standard deviation.
For 3, you just plug in the number. Oh, the margin.
Yeah, so we're just doing the same thing we did before, right? The plus or minus.
Yeah.
Like it.
Okay, so it will be 90% is
1.645.
5
Yeah.
minus. Wait a minute.
Wait, but since there's 2 different
Wait.
numbers, wouldn't there be 2 different slots?
No, number 3? Oh, yeah, you're right.
So, maybe like write the number for one and comma and the other.
I don't understand why there would be 2 different numbers.
Well, because they want the margin of error, so it's always between two different points.
Oh,
Oh, that's right. That's right.
Right?
okay.
So, yes, ma'am?
Oh, no, good. But then to decide the margin of error, we see how much space is, how many number of spaces is in between them, and then we stick them in, don't we?
Well, I feel like there's a number missing here if we're going to use that formula we were using before.
I don't think. Oh, yeah, you're right.
Aren't we missing a number?
Well, they just want the margin of error. They don't want the two numbers.
Okay, so we're using a different formula then. We're using that.
I think we're using the same formula. We are just finding the margin of error, not.
So
the
it's,
number
so it's m equals z over, or standard deviation divided by the square root of n, right?
Mm-hmm.
So that's the. Is everyone agree that's the formula we're going to use?
Yeah, and I think this is the formula you were talking about, Seri, that has sigma over the standard, no, over the square root of n.
Yeah. So it's the z score times the sigma over square root of n, right?
Yes.
Okay. Woohoo!
So
Okay.
the z square is 1645.
Give me 1 second, sorry.
Sigma.
Standard deviation.
Oh, well, tower.
Whoops. Oh gosh. I am
It's 50
over.
and it's 25.
Okay. This is number 3. 645 times 50 over 5 equals 10.
Is that 16.45?
That's what I got.
That's what I got too.
Round to 3 decimal places, so it just would be 16.450, right?
Yeah.
Yeah.
Okay. The following statements is true. Oh, I don't know.
Yeah, that's how I feel too.
I want to say that X bar is a point estimator of U. But point estimator and interval estimator. Let's look this up.
Well, we know the last one is not true.
Okay, here we go. Point estimators. Think about
So
if you use
we have sample statistic and we have population parameter. And so X bar is the statistic for the parameter of U. S is a statistic for the parameter of sigma. And S to the square is a statistic for the parameter of sigma to the
Right.
square.
Okay, so you're looking at that little box, right? That little
Yeah.
Yeah.
point estimators. Okay, so based on that, then. Okay, so then X is a point estimator of U, right?
Yeah.
Mm-hmm.
Yes, S is a point estimator of mu. Mhm.
Okay. So then that would be our answer, right? Because everything else is.
Yeah.
Hold on.
Yeah.
Yeah.
4 is C.
Okay. Cool. That's what I thought. Student wants to construct a 95% confidence interval. She knows standard deviation closest and. What is the lower limit of the confidence? Okay, so this is the one we'll do the plus or minus of, right?
Yes.
Number 5.
Yeah, what is the lower limit and then what is the upper limit? So that one makes sense.
Okay, so 95 is 1.60. Okay.
She lost her shoe. Where did it go? No.
Wait.
I lost my formula.
1.96. 1.96. 13 over the square.
So what is our X bar on this problem?
526.
Okay. Oh, there it is. Oh, I'm so blind.
It's okay. I'm looking. Sometimes I
Like,
look at the wrong problem.
letters.
I'm pulling numbers from the problem above. I'm like, oh, come on, woman. Okay.
Yeah, I do that too.
Okay. When it's okay.
Takes me longer to figure out where numbers go than to punch it in the calculator.
Oh yeah.
Hold on, I gotta go get my daughter. Olivia. Okay. You guys get the answer?
I got.
Okay, so.
So I got 498.315 for the lower limit and 553.685 for the upper limit.
Yeah.
Oh, I must have
I got
done something wrong.
No, I got 543.315 and 589.685.
Yeah.
I got 503.4 for the lower and 548.6 for the higher.
And Natalie,
I
what about
got
you?
what you got, Sadie.
Okay, so let's walk through the whole thing then. Let's talk. Sadie,
Okay.
give us your equation.
Okay, so I did 1.96 times 113 divided by the square root of 64.
Okay, so our equation is x
No,
bar.
that's what I did wrong. I inputted 1.60 instead of 1.96, so mine is completely wrong.
Well, I did. Okay, so we're doing the x bar plus or minus our z-score, right? Times the standard deviation divided by the square root of n, right?
Yes.
Okay, so our x bar is 526, so I did 526 minus the z-score of 1.96, right?
Mhm.
Okay, times 113 divided by the square root of 64, right?
Yes.
Okay, so let me work that again, because maybe I punched it in wrong. Okay. Because why did I get a completely different answer? Okay, so I'm going to go. So the square root of 64 is 8, right?
Yes.
So 113 divided by 8 is 14.125. Now I multiply that by 1.96 times 1.96 equals 27.685.
Yeah, and that's going to be your margin of error on each side.
And then I subtract that from 562, right?
From 526.
Oh, yeah. 526?
Yes.
Oh, look at that. I switched the numbers. That's why. Okay. That's where I went wrong. I think I have dyslexia sometimes. Good to like talk it through with you guys, because then I'm always like, where did I go wrong? Okay, so you're okay. So then if I do that,
So then for the minus area, I did get 498.315, and I'm still working on the higher part.
8 equals. Okay, 498.31. Okay, there we go. And 526 plus 27.685 equal 553.685, right?
Yes.
Okay,
Yeah.
woohoo. Man.
So then 5 is 498.315,
Yes.
and 6 is 555.685.
I got 553.685.
Yeah, I
Yeah,
got 553.685.
0.685, yeah. 498.315,
Okay.
and then Olivia, 0.685. Okay. 7. So what would happen to the width of the confidence interval if Gina increased the sample size?
If the confidence interval will decrease, right?
Yeah, that's what I
No,
thought.
wait.
No.
No, wait, it's a confidence interval, not that. Okay,
Yeah.
not
I
the
thought
margin of
it would
error.
increase.
So then it would increase.
Yeah.
Are you sure? I think they have the answer for it on 4.2 in the reading.
What's that? Oh, it's the answer for
Okay,
4.2?
Yeah, in the reading, it's in 4.2.
Oh, okay,
Let
let's
me
see.
find it. Oh, shoot, I was right there. What did I do?
Uh,
Oh, I lost it.
4.1. Okay.
4.2.
Okay, so are you looking at what would happen to the confidence interval if the sample size was increased? Since the sample size is increased, then the fraction would decrease, which leads to a smaller margin of error. In other words, the sample size increased, the width of the confidence interval would decrease.
Yeah,
Okay.
so it would be decreased, right?
Yes.
Okay. So let's put down decrease.
Okay. Olivia, please. You want some fruit snacks? Yes or no? See? You want to go take some to Sissy? Go take those to Sissy? Go take those to Sissy. Go! Good. Oh, well, no, here, I'll see.
Sadie, where are you from?
Seattle.
Go take those.
Seattle.
Go take those to Sissy. Go take
And
those.
you, Natalie?
From California, Oceanside.
California.
Okay, sorry.
That's okay.
We do 8.
No, we
What-
haven't done 8.
What would happen with the width of the confidence interval if Gina changed it to a 99%? So it was at, what, 95? So it would get a larger, right?
Small.
Increase?
Increase.
Yeah. Right?
I wish.
That's also in 4.2. That's actually number 7 in 4.2.
What would happen to the confidence interval if the confidence level were increased from 95 to 99? Increasing the confidence level would lead to a larger z-score, and the z-score and the margin of error would increase. This would lead to a wider confidence interval. Yeah, it just makes sense because you're going, if you think about it from the applet, like if you were to type in 95 on the applet, it would be like maybe like this, and then you would type in 99, you'd get like a larger area.
Yeah, okay.
Right? So it would
That
just go
makes
from
sense.
this to this.
Increases. Okay. Okay. Variable label.
Oh, okay.
So then this one will need
This one's the one
what's
with the sample
the
size, right? The sample size.
yeah, z times sigma over m and all that to the square.
Okay.
Okay.
1.96 radiation.
Number 9. Okay. What's the z-score for 95 again?
1.96.
Okay. Sorry, I need to memorize that.
Yeah, me too.
Oh, that's okay.
We're learning. It's okay.
1.9
So do we need to find M first,
times.
since it's not
I
given to
thought
us?
M was 50.
Yeah, the margin of error is 50 hours.
Okay, yeah.
Times sigma, which is 400, divided by D. Okay.
Did anyone else get 246?
I'm still
did.
trying to figure out what numbers there. Sorry.
What'd you get?
Now I can.
246?
I got 246.
Yeah, 245.8, which rounds up to 246, right?
Yeah. And we always round up anyway, even if it's like 1.1.2.
Yeah. Mm-hmm.
240.
So what did you girls get again?
246?
Okay, yeah, 246.
You are interested
Okay.
to know if these are for women. Sure.
Living salary. Notion, you're interested in elements. So different from the population, but you're not sure if it's higher level.
Ugh.
Wow, this is a lot of information.
What is the lower limit of the 95% confidence interval? Okay, so we want the hypothesis test.
No, well, we're doing the same formulas again, right?
Yeah, the plus or minus.
Plus or minus. Mm-hmm.
But we just have to figure out which ones to plug in, right? So you collect a random sample of 36 women's salaries and find that X is equal to, use this information. Okay. Okay, so we're going to go, so what is the 95%? 10. And the 95 confidence interval is...
So is everyone else doing 1.96 times 0.05 divided by the square root of 36?
Wait, come again? I'm sorry?
No, wouldn't it be, well, I was going to do 1.96 with plus or minus the X bar, which is 111,000, times the times 36,730 over the square root of 36.
Okay.
Right? Because we don't need the level of significance, right?
Yeah, you're right.
Yeah, we don't need the level of significance. So, goodness, I'm so lost now. So wait, what are you doing again?
So I'm doing the 1.96 plus or minus the 111,000, right? Times our standard deviation, which is 36,730, divided by the square root of our sample size, which is 36. Right?
Okay. I was having a time interpreting so many numbers.
Wait a minute. Did I shut that up right? No, I didn't. What am I doing? Come on, woman. I just realized I set my problem up. My 1.96 was on the wrong side.
Oh goodness.
Minus.
I must have done something wrong. I got a negative number.
30 divided by 6.
Oh, what did girls get?
For the lower limit, I got 99,002, and for the upper limit, I got 122,998.
That's what I got.
Okay, I am getting, I don't know if we're getting a negative number, so I did 196 minus, and I set the parentheses in the, what do you call it, calculator. I did 100, okay, I typed in 1111,000 times 36 and 3.
Well, I think what you did is that you,
36.
Giselle, I think you probably did what I did because that's what I rattled off it. But I switched the 111 to 1.96, so it should be 111 minus 1.96 times 36,730 divided by the square root of 36.
Okay.
To just have those two numbers flip-flop, the 111,000 and the 1.96.
Okay. Yeah,
That's
I think so.
It's probably my fault because that's what I said.
No. It's okay. Don't worry about it.
Sorry. Okay. So tell me again, Sadie, what you got for the lower limit?
For the lower limit, I got 99,002, and for the upper limit, I got 122,998.
Okay, cool. I think that's what I got here. Let me add plus 1199.8. So 122,998.4. So 122,999.
It would be 98.
98. I rounded down.
So it's 0.4.
Oh, okay. Oh yeah, you're right.
998.4.
Wait, so on 10, I got 99,001.5333333.
So you round up because 5.
We're supposed. So I put 9, 0, 0, 1 point. And the answer
What was that?
is whole number. So
Is it just me, or does the cell break up a little bit?
Yeah, she's breaking up.
Okay.
I'm sorry. Okay, so just tell me what to write on number 10, and I'll write it down.
Okay. So that 10 is the lower limit. Okay, which
Yeah.
is 99,002, right?
That's what I put.
Yes.
Okay.
Just want to talk, huh?
And for 11,
And 11 was, what was it? 122,998?
Yes.
Mhm.
okay.
All right. So you guys didn't put the decimal point or anything, did you?
No.
Okay, good.
No, it's
Around
this
to
whole
the
number.
whole number.
Okay, cool. All right, so 12. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are simple random sample, X is normally distributed, and sigma is known, which is all of them, right?
Yes.
Yes.
Okay, whew. You guys ready to submit?
I am.
Wait. Okay, hold on. Oh, there we go.
And we got them all right.
Woohoo!
Good job. Yay.
All right, sweet. That wasn't so
Oh,
bad.
shoot. I must have typed in 6 wrong.
Oh, number 6?
Mm-hmm.
What'd you put?
555.685.
Yeah, it was 553.685.
5553. Okay.
553.
I'm terrible. Oh, by the way, for the test, I sent all my work, the pictures of all my work, my paperwork, sorry, to the teacher.
Uh-huh.
Yeah.
And what he saw is that I was, on paper, they were right, but I transferred them wrong so I typed them in wrong.
Oh, no. Oh, good. Well, did he fix your
He
score?
still gave me credit for. Yeah, he did. So I ended up getting an 85 instead. But
Yay.
Nice.
Well, that was smart of you to, like, show him what you did, show him your work.
Mhm.
yeah, so you might want to do the same thing.
Yeah.
Okay.
I think I'll
I do
email.
that a lot. Just type the wrong numbers.
Cool. Okay. Well, same time, same station on Thursday?
Yes.
Yeah.
Okay. See you ladies in a couple days.
Bye.
All right, bye.
Okay. Bye.